Okay, welcome back. I hope everybody has been able to successfully watch the first video. If you have any commentary, if there's any problems accessing the material, or if you just have some criticism that isn't too harsh, I would appreciate hearing from you. I hope everybody is doing okay in their own lives and that things aren't too difficult for you. So today we're going to go ahead and we're going to start in on the skeletal system. And I've broken them down into appendicular and axial components. In lab, we've already started with the appendicular skeleton, so that's where I'm going to begin with the lecture. The human skeleton is divided into approximately 206 bones in the average adult body. Obviously, when you're a kid, you have a lot more bones because you still have those epiphyseal growth plates. So if an individual does die when they're a child, and all that cartilage breaks down, then the long bones will end up being in 3 separate pieces. But as an adult, once the epiphyseal plates have all been replaced by the epiphyseal lines, then on average you'll find 206 bones. We divide them into the axial and the appendicular skeleton. In red, you can see here what we consider to be the axial skeleton. This is made up of the skull, your vertebral column, and the rib cage, which includes the sternum in the front and then the individual ribs or costa on the sides. In general, if you just focus in on this part of the skeleton, notice this is where we found a lot of the cavities. So these are the bones that are going to protect organs, okay, such as the organs in your thoracic cavity and in your cranial cavity. They also are where you're going to find most of the special senses. Those are going to be focused in on the head. And then finally, of course, protecting the brain as another type of organ. The hemopoietic tissue here is going to be found in fairly small amounts. It's found within the spongy bone. If you remember, a lot of these bones are considered to be flat or irregular, and they do have spongy bone within them. But the large majority of hemopoietic tissue is going to be found in the other portion, the appendicular skeleton. Here in light red, you can see outlined the appendicular skeleton. These are focused on locomotion. So we have the arms and the legs. Obviously in humans, we're talking about the legs, but remember we did have a quadrupedal ancestor, so once upon a time, arms were pretty important for locomotion too. And then these bones referred to as girdles. And the girdles are what articulate or connect, forming joints between the arm and the axial skeleton and the leg and the axial skeleton. So we're going to look at these girdles as well. Okay, starting off with the pectoral girdle. So the pectoral region, right, that gets its name from the muscles that are found in the front of the chest. And the pectoral girdle consists of 2 bones on each side. You have a clavicle and scapula on both the right and the left-hand side. If you were to look carefully, you would find by studying a skeleton that the pectoral girdle is barely attached to the axial skeleton. So if you study these, and you can imagine how they articulate, if you've already started to study the bones, you would find out that the only place there's an articulation between the pectoral girdle and the axial skeleton is here at the sternal end of the clavicle, which forms a joint with the sternum, okay? There's also quite a shallow articulation between the pectoral girdle and the humerus. What this really means is that the connection between the humerus and the scapula is this wide, not terribly deep articulation. So what it means is that you can really move your arm through a wide range of motion. So imagine circling your arm while holding your body still. But on the other hand, because it's a shallow articulation and it's just held in place by ligaments, it's also prone to dislocation. So if you've ever known anyone who suffered from a dislocated shoulder, it's not that uncommon. On the other hand, we'll see that the other girdle has a much stronger type of articulation. So here's our second girdle called the pelvic girdle. And this bone here indicated with the letter A, this entire bone is the only bone that makes up the pelvic girdle. So there's one on, this would be the right side, one on the left side, okay? And these also have only a single point of attachment. Okay, this bone that you see here, we haven't gotten to yet. This is the sacrum, and it's part of the axial skeleton. So actually the vertebra will go up this way. So right here, this sort of ear-shaped structure, that's the point of articulation. And it's a much wider, stronger articulation. Okay, so there's a much stronger connection here between these two than we saw between the sternal end of the clavicle and the sternum. And in addition, the connection between the pelvic girdle and the leg, which is going to come off here, there's a very deep, strong attachment between the pelvic girdle and the bone we'll call the femur. And this results in a narrower range of motion in the hips. So the average adult can only move their hips to a narrower circle than what you can do with your shoulder, unless you are very well trained as a gymnast or something and you've stretched those ligaments over a period of years. Okay, now we're going to the first of the long bones of the arm. This is the humerus. Now you've gone over all of these already, or if you haven't, you might want to look over that before you continue this lecture. But we did learn in watching the video that identifies all of the structures of the humerus that there are 3 fossa, or I've also heard it called fossa, either one. And a fossa or fossa is a shallow indentation. Okay, so these 3 you can find here. Now, you got to pay attention to the label. So this is labeled anterior view and posterior view. So there's one large fossa that you can see from a posterior view called the olecranon fossa. And that's going to correspond to that area we learned of as the olecranon region. So it's the back of your elbow, essentially. And then there's 2 smaller, shallower fossa that are found on the anterior surface. And again, we're down here at the elbow. So this is the distal portion. So is this. These are the distal portions of the humerus. And there's going to be a coronoid fossa that sits just superior to the trochlea. And then there's a second, quite shallow one here on the anterior surface that sits just superior to the capitulum. And that's known as the radial fossa. So these 3 fossa, if you think of them as indentations, they are going to allow projections of other bones, specifically the radius and the ulna, to sit in the fossa when you extend and flex at the elbow. So hold your arm straight out in front of you. Okay, that is extension of the elbow. So that means that there's a straight line between the humerus and the radius and ulna. Now, if you bend your elbow, that's flexion. And when you do that, projections on the radius and the ulna slip quite neatly into these fossa. And it allows you a greater range of motion. And when you hold your arm straight, there are structures associated with the ulna that slip right into the olecranon fossa. So really, what these fossas do is allow you a greater range of motion. Okay, now let's look at the structures that fit into these fossa, what we're calling projections. Okay, so here we are looking at the proximal ends of the radius and the ulna. So for proximal, it's going to be closer to the elbow. This guy here that has this apparent letter U, that's the ulna. It's an easy way to recognize the ulna. And then this nice, round, smooth structure is referred to as the head. This is the radius. Okay, so when you straighten your arm out, this process here, the very end of the ulna, is called the olecranon process. So it's going to fit into the olecranon fossa when you extend your elbow. When you flex your elbow, right, bringing your hand towards your shoulder, the coronoid process is going to tuck into the coronoid fossa. And the radial head is going to go ahead and tuck into the radial fossa. So notice a lot of these names are similar. So as you're tackling all of these different structures, if you can understand how they fit together, which is difficult to do without actually having the skeletal material to study, but the similarity in names reflects the interactions between, in this case, projections and fossa. So if you take a look, this is showing you the elbow joint. And here you're looking at the elbow when it's extended. So the arm would be straight out, okay? And we're looking from a posterior view here on the right elbow. So the superior bone is the humerus. This large bone here that is oriented more to the left side of the image, that's the ulna. And then you can see just the head of the radius peeking out. So while the arm is extended, the olecranon process is sitting in the olecranon fossa. Whoops. And then if you look from the anterior view, here's the head of the radius, and here is the coronoid process. And those two, when you flex, are going to fit into the fossas that have the same name. Okay, so you can see here how the olecranon process sits into the olecranon fossa when you have the elbow extended. Now here we're moving down to the radius and the ulna. Now to remember the locations of them, the radius, it's stupid, but I call it the rad bone, R-A-D. So radius, I want you to think of some dorky guy with his thumb up in the air, you know, thumbs up. So back in the 80s or whatever, when people said rad. The whole point is for you to remember that the radius goes to the thumb. So think of thumbs up for the radius. So here's the radius, and if you follow that bone down, boy, I keep doing that. If you follow that bone down to its distal portion, it's going to lead you to the thumb. Okay, so the radius goes to the thumb. That means the ulna goes out to the pinky. All right. Now, these two bones have two joints. They have a proximal joint and they have a distal joint. When you hold your hand straight out in front of you so that your palm is facing up, we describe this as supination. So I want you to imagine you're holding a bowl of soup in the palm of your hand. And notice in supination, these two bones run parallel. Now, go ahead and rotate your palm so it's now facing downward. So at this point, your thumb should be medial and your pinky should be lateral. Pause for a minute and think about it if you need to. Okay, but when you do that, you get the image you see here on the right-hand side, known as pronation. Okay, so the humerus hasn't gone anywhere. Notice the humerus remains perfectly still. But in fact, what happens is that the distal portion of the radius crosses right over the ulna. So you can do this also by holding on to your forearm as you go from palm up to palm down. And you'll feel this crossing action. Okay, this is known as pronation, and it's an unusual movement. We're going to get into how you move at joints more later. Okay, but this is the only part of your body that can do this pronation and supination. So play around with your own arm a bit and see how this works. Okay, next we've moved down into the carpal bones. So you can see that the radius, the distal radius, remember, rad bone, it's going to the thumb. The distal radius articulates with two bones, two of the carpal bones. So if you've gone through that already, you could try the mnemonic some lovers. So that's what I use is some lovers try positions that they can't handle. Okay, two rows, one row that articulates with bones of the forearm, the antebrachial region, and the second row that only articulates with the metacarpals. Okay, so going back, the radius is going to articulate with two bones, the scaphoid, some, and the lunate, lovers. Okay, so these two form a joint with the radius. And the ulna only articulates here with the lunate. Okay, so of all these 8 carpals, the only 2 that form a joint with the bones of the antebrachial region are the scaphoid and lunate. Okay, and And how many carpals? I've already said that. There are 8 carpals. Okay, now let's move down to the pelvis. The pelvis is not the same thing as talking about the pelvic girdle. The pelvic girdle, I told you, was just one bone on the right, one bone on the left. Okay, so the pelvic girdle is this bone here, the os coxa. Okay, so there's a right os coxa and a left os coxa. But the structure known as the pelvis, and this is confusing, but it's not the pelvic girdle. The pelvis is made up of 4 bones, the left and right os coxa, but in addition, we include the sacrum and the coccyx. So the sacrum is the large bone, here it's shown from a mid-sagittal, the large bone that articulates with, in this case, the right os coxa. And then the coccyx is this inferior most of the vertebral column. You probably know it commonly as being the tailbone. So the importance about the pelvis is actually, this is the biggest bony difference between males and females. And it has to do with the need to survive childbirth, which exerts a great deal of pressure on the shape of female anatomy, meaning that a lot of women used to die in childbirth. Humans have unusually large-headed babies, and it's very difficult for females to survive childbirth. A lot of the mistakes are, of course, things that doctors have done to women over the years, or the use of various interference techniques. But the fact is that giving birth is dangerous for female humans. Men, on the other hand, don't have that, and so in fact their pelvis is quite different. So let's look at those constraints that we talked about that women have. Okay, there's a structure here referred to as the pelvic outlet and the pelvic inlet. This color-coded image on the right, these two right here, are quite helpful. You see this purple circle. It goes from the top of the pubic symphysis and draws all the way around to the top of the sacrum. And you can see it over here as well, shown with this solid blue line. Okay, this space here is referred to as the pelvic inlet. So during childbirth, the baby's head will descend into the pelvic inlet and then has to pass out of this space here shown in purple. This whole space is the pelvis, or what we were talking about before is the pelvic cavity. So that space, remember when I showed you how the bladder and so forth occupy a space very deep in the pelvis? Okay, that's the true pelvis, or what's called the pelvic cavity. And then the very bottom of this is the second of these, known as the pelvic outlet. So the baby's head has to make it into the pelvic inlet and then out the pelvic outlet. And the pelvic outlet is limited by the pubic symphysis in the front and the bottom of the coccyx in the back. And then over here, we have additional bony structures. So the important thing, here they are. Okay, the ischial spines. So in fact, what is usually the most difficult part of surviving childbirth for the baby and the mother is getting the head to pass through the pelvic outlet, because this space encircled by those structures, this space is quite narrow. Okay, men, because they don't give birth, these spaces will be even smaller. The pelvic inlet and the pelvic outlet on a male pelvis are considerably smaller. All right, the last thing I want to talk about is what's called the false pelvis. And that's this area or space filled up with the color blue here. So anything that sits above the pelvic inlet is referred to as the false pelvis, because actually this space in here is within the abdominal cavity. Okay. So the true pelvis is deep to the pelvic inlet, and the false pelvis is actually abdominal cavity, and that sits superior to the pelvic inlet. So if you look at an os coxa, you can recognize fairly easy whether you're looking at a male or a female skeleton. And this is where I really miss us being in the lab because we have both female and male examples. But some of the terms that you learned when you were studying the bones will come in handy here. Okay, so the male, oh, I guess we haven't gotten to this yet. So you will be working on the os coxa later. We haven't gotten there yet. So far, we've just done the arm. So after you watch the second part of Unit 2, week 2 of Unit 2, then you'll know this information. But there's a structure here called a greater sciatic notch. And here it is on this pelvis. Notice how they're different. This greater sciatic notch is quite deep, but not terribly wide. This one, on the other hand, is considerably wider and not as deep. So we see a male os coxa pictured above and a female os coxa pictured below. If you're looking at the entire pelvis, remember that's 4 bones, you can see additional differences. Okay, this right here is called the pubic symphysis. It's where one pubis bone meets another pubis bone. And the pubis bone, as you'll learn next week in Unit 2, is part of this os coxa. Okay, so here at the pubic symphysis, you can go just below that and measure the angle formed where the 2 pubic bones meet. If that angle is less than 90 degrees, so 90 degrees is a right angle, then that's going to be characteristic of a male pelvis. And that is usually really easy to recognize. If that angle is above 100 degrees, so more than a right angle, then that's a female pelvis. Okay, other differences, the ilium, which is the top part here of the os coxa, it's more upright in a male and it flares outward in a female. Whoops, sorry about that. Okay, and then the last thing is the, actually that's it. So just look at the subpubic angle and the shape of the ilium. That, along with the shape of the greater sciatic notch, can really help you to determine if you're looking at a male or a female skeleton. All right, so now we're moving down toward the leg. This will be new information that you'll get to soon in lab. Okay, but we're looking at probably the most complicated joint of the body. This is the knee. Notice for the knee, it's somewhat like the elbow. Remember, the elbow is where 3 bones come together. That joint is formed by 3 bones. Now, in the knee, first of all, we've got an extra bone, the patella. And if you remember from the previous lecture, I told you that this was an unusual bone because it forms in the membranous tissue. Okay, so we have the patella or kneecap. And then the femur, unlike the humerus, only articulates with one of the lower leg bones. Okay, so remember the humerus touched both the radius and the ulna, made a joint with those 2 bones. Here, the femur only articulates with the tibia, and the fibula is sitting off to the side. It articulates with the tibia, but not with the femur. Okay, so the femur articulates with the patella, here on the patellar surface, and inferior with the tibia, but not with the fibula. So the fibula is not, strictly speaking, a major bone in bearing your body weight. So if you were standing there and suddenly you're standing upright and suddenly you could snap your fingers and make your fibula disappear, you wouldn't fall to the ground, right? As you would if your tibia could disappear. It does, however, support lateral movement of the leg. Okay, so based on what I just said, which bone bears most of the weight between the tibia and the fibula? Okay, and the answer for that is, of course, the tibia. The tibia bears the weight. And the why, sorry, I thought I had it written out. Why is just because all the weight coming down the femur is going to articulate with the tibia. So it's going to pass the stress of your body weight down to the tibia. Some of that weight will be carried through the fibula, but not a lot. Okay, now let's move on to the tarsals. How many tarsal bones are there? Well, there's only 7. It's a little different from the carpals, which have 8. And this one right here, we're looking at a right foot from a superior view. This one right here is called the talus, and it is going to make an articulation with the tibia. So if you were to sit down and to lift your toes skyward, decreasing the angle at your ankle, okay, you would be moving the tibia at its articulation with the talus. Okay, you'll get to more detail on the bones that make up the tarsals in lab. Last thing I want to talk about here are the arches of the foot. Okay, so you've probably heard of people having high arches or fallen arches. That's what we're talking about. And the major arch is this first one, the medial longitudinal. So we're looking here at a medial view of the right foot. So this is the inner arch of the foot, and the one that most of us are talking about when we refer to an arch of a foot. It runs from the hallucis, right? That's the big toe, back to the calcaneus. That's the tarsal bone that we call the heel. It's also where the calcaneal tendon attaches, right here. Okay, so this large arch is the medial longitudinal. Okay, and then if you look from a lateral view, there's an additional longitudinal arch back here on this side. So that's the lateral longitudinal arch. It runs from the pinky toe, there's your pinky toe right there, all the way back again to the calcaneus. So both of these run longitudinally. And notice, by the way, here's a sesamoid bone. So remember, that's like the kneecap, the patella. It forms in tissues. And we do have some examples of that in lab, but unfortunately I can't show them to you. So if you did have a sesamoid bone here, that would make it, as an adult, that you would have more than 206 bones, because this is an extra bone. All right, last we're going to look under what we might call the ball of the foot. This is a transverse arch, and we're seeing it by looking through a transverse section of the foot. So it runs under the distal tarsals and metatarsals. Okay, so if you look from the side, here are your metatarsals, okay, and your distal tarsals, that's this part right here. So if you could go under the arch, it would be right under here. So the important thing about these three arches is they help the body to absorb the shock of your body weight pushing down as you walk. So every step you take, your body weight is transferred down to your foot. And so these are kind of like shock absorbers. And these arches are maintained by the shape of the bones, but also by the ligaments. Remember, those run bone to bone. And then the tendons that connect the muscle to the bone. So there are some professions where people tend to suffer from what we call flat feet or fallen arches, where the body weight over time stretches these ligaments and tendons, and the feet lose the arches. They lose their shock absorbers, which means you're just more prone to painful feet. Okay, let's do a couple of review questions. You can always slow this down, answer the questions first, and then go back to look at the answers. So you don't have to watch this in real time if you want to quiz yourself and see what you've learned. Okay, name the tarsal bone or bones that articulate with the leg. Okay, this is the talus, and it will articulate with the tibia. Only one bone of the os coxa is found in the false pelvis. Name it. So if you think about, I mentioned this name briefly when we were talking about the flared shape of the female pelvis. Okay, and this is a bone called the ilium, and this will make more sense to you after you study the os coxa. Name the fossa and projections that fit each in the elbow. So go back, see if you can remember the names of those three projections and the three fossa, and think about how those work when you extend and flex at the elbow. So when you extend at the elbow, the olecranon fossa receives the olecranon process. When you flex or bend your elbow, then the radial fossa will fit within the the radial fossa, the head of the radius, and the coronoid fossa is going to receive the coronoid process. Sorry if you hear that in the background, my dog is grooming himself. Okay, what does the fibula do? Okay, think about the fibula. Okay, it's a site of muscle attachment. It stabilizes the ankle and the lower leg, but it is not directly weight bearing. Okay, compare and contrast the bones of the hand and the foot. So once you've completed studying the hand and the foot, I want you to think about in what ways are they similar and in what ways are they different. Basically, it comes down to you have one additional carpal versus your tarsals. So you have 8 carpals and 7 tarsals. Otherwise, the metacarpals and metatarsals are very similar between the two, and the number of bones that are found in the phalanges are identical. Compare the knee joint to the elbow joint. I talked about that. Okay, so for the knee, you've got 2 bones articulating. That's the femur and the tibia, plus the patella, which articulates with the femur. But in the elbow joint, you have 3 bones that articulate to make up that joint, and that will be the humerus, the radius, and the ulna. Okay, this concludes the first half of the lecture on the specific bones of the skeleton. Take care and let me know how you're doing. Okay, bye.